So we're done discussing summation. Let's proceed to another topic also highly related to summation notation. So this is sum of squares. This is denoted by this notation. We have summation of x squared, or simply saying the sum of squares of variable x. Take note, we've used here variable x because what's given here is x. But if you've written here summation of y squared or summation of z squared or summation of a squared, then this should be read as sum of squares of variable a, variable z, or variable y, because this letter is a dummy variable. But is most books or literatures, they are using X. There are some literatures that they are using other letters. So again, going back to using X, for this one, it's the sum of squares of variable X. So it's the sum of all the squares of the elements X, squaring each value of X, then getting the sum. Or simply saying, the first thing that you need to do is to square each value of x. After squaring all the values of x, you get their summation, or you try to add all of them. So let's proceed to the statistical proper. So we have this summation of xi squared from I equals to 1 to I equals to n. Or the other way of reading this one is the same story. The summation of x I squared as I goes from 1 to n. And n here could be any other number. And I is the summation index. Xi squared is our term. Okay? Term or formula term. So if we're going to expand this one, this is what I am telling you a while ago. Summation of xi squared as I goes from 1 to n is written as x sub 1 squared plus x sub 2 squared plus x sub 3 squared dot plus x n squared. So this dot refers to all the values ranging or in between x sub 3 squared or x3 squared up until you would reach the last value corresponding to xn squared. So using the same data that we have used in the previous problem sets. So we will be using this one. Again, we have 5 samples. So this pertains to the weights of the 5 children. X1 corresponds to child 1, X2 corresponds to child 2, X3 corresponds to child 3, X4 corresponds to child 4, and X5 corresponds to the 5th child. And each of those child or of those children, they have their equivalent weights. So child 1 is 10 kilograms, child 2 is heavier, it's 12 kilograms, child 3 is 14, child 4 is 8, and child 5 is weighing 11 kilograms. So given this values of x, we could actually write a summation notation. If we're going to have, we could have a summation for the sum of squares. So to do that, this is the answer. Summation of xi squared as I goes from 1 to 5. So to write this, we have x1 squared plus x2 squared plus x3 squared plus x4 squared plus x5 squared. This is the expanded form of this notation. Since we already know that each of this x here has its equivalent value, we then substitute. So x1 is 10. You can see it here. It's 10. So replace it 10 squared plus x2 is child 2 is 12 kilograms. So replace x2 with 12. So we're going to square it. x3 or child 3 is 14 kilograms. So just square 14. So 14 squared. x4 is 8 kilograms. So child 4 is 8 squared. And then the 5th child is weighing 11 kilograms. That's why we have here 11 squared. So squaring each of the value of x. So 10 squared is 100. 12 squared is 144. 14 squared is 196, 8 squared is 64, and 11 squared is 121. After squaring each value of x, we then get their sum. It's 625. That is the sum of squares of the weight of the 5 children. Take note that we have squared each value of x, and after squaring, we add all of them. That's why it's called the sum of squares. Now, it's your turn to answer the problem set. Now, let's try this. Hashtag Simpletivity. I want you to think and use, of course, your brain cells. So, how do we read this? Can you read this one? Okay, so let's read it together. It's summation of I squared as I goes from 2 rather to 4. So again, summation of I squared as I goes from 2 to 4. Or the other way of reading this is summation of I squared, which is I is equal to 2 to I is equal to 4. Again, summation of I squared from I equals to 2 to I is equals to 4. I hope you could already master reading summation notations. Okay. Or reading these different notations. Since this is sum of squares, let's try answering this. So to answer, first thing that we need to identify is what is the formula of the term. The formula of the term is I squared. And then, what's the index of summation? The index of summation is I. What is the starting value? Okay, it's 2. And it ends at 4. So I squared is, we just need to replace the real value in the summation index. So 2 squared, because it's I squared, it ranges from 2 to 4. So 2 squared plus 3 squared plus 4 squared. 2 squared is 4. 3 squared is 9. And 4 squared is 16. That's why we have 29. So first, squaring each value of x and then adding all of them. That's why it's called sum of squares. So the answer for the summation I squared as I goes from 2 to 4 is equals to 29. I hope you got the same answer. Another one. We have this given values for x. So x sub 1 is 3, x sub 2 is 6, x sub 4 is 4. Or rather, x sub 3 is 4 and x sub 4 is 7. Let me repeat. X sub 1 is 3, x sub 2 is 6, x sub 3 is 4, and x sub 4 is 7. We need to find the summation of x plus 2 squared. Okay? So the summation of x plus 2 squared. So how to get this one? We simply substitute the values of x to this notation. So to get that, first one is we need to get the values of x plus 2. So 3 plus 2 is 5, 6 plus 2 is 8, 4 plus 2 is 6, and 7 plus 2 is 9. So if we're going to get the summation of x, we have 20. If we are going to get the summation of x plus 2 squared, or rather x plus 2, wala pa munang squared, it's 28. Now, we are going to square each value of the formula term or the term. So x plus 2 is 5. Squaring this, it's 25. 6 plus 2 is 8. Squaring this one is 64. 4 plus 2 is 6. Squaring 6, it's 36. 7 plus 2 is 9. If we're going to square 9, it's 81. So 25, we're done squaring each value of the term, the formula term. So after getting the squared of those values, then we are getting the summation. So the summation of x plus 2 squared is equals to 206. So ganun lang po siya kadali. Another example is, let x be the number of days with extreme rainfall excluding typhoons in a certain municipality here in our country. So we have this x sub I. So it ranges from I1, I is equals to 1 to I is equals to 5. So x sub 1 is 27, x sub 2 is 26, x sub 3 is 18, x sub 4 is 28, and x sub 5 is 34. So first one is we're asked to get the value of x sub I as I ranges from 1 to 5, or I is equals to 1 up to I is equals to 5. And the second one is to get the sum of squares. So summation of xi squared as I goes from 2 to 4. Please try to remember these values. So let's start solving for this. So given the following values of x, so summation of xi as I goes from 1 to 5. So we know that we have 5 different values of x. So x sub 1 or x1 is 27. We have the second value, which is 26. The third one is 18. The fourth one is 28. And the fifth one is 34. Then we simply get the summation of all those values, or we simply get their sum. Simply add all of those terms or values. Then the second one is summation of xi squared as I goes from 2 to 4. So squaring each values of x. But remember, the summation index is I, and it starts with the second value up to the fourth value of x. So we try to exclude the first value of x and also exclude the fifth value of x. So let's start with the second value. And the second value of x corresponds to 26. The third value of x corresponds to 18. And the fourth value of x corresponds to 28. So 26 squared plus 18 squared plus 28 squared is equals to 1,784. So this is a simple summation notation. This is a simple summation, and this is a simple sum of squares. Getting the sum of squares. So let's proceed to our stat techniques. Hashtag stat techniques. So sum of squares is given by this notation. So summation of x squared is the sum of square. So what's the best thing in order for us to be familiar about the sum of squares? First is squaring the numbers before they are summed. So square each values of x first. After getting the squared value, we simply add all of those terms or values. So that's sum of squares. Earlier, we have learned that sum of squares is simply squaring each value of x and then getting their summation, or squaring each value of x and then after which adding all of those squared values. So let's proceed now with the square of a sum. Notice that in sum of squares, we did not find the parenthesis, but in square of a sum, we actually can notice, or it's evident that parenthesis is present. So let's start defining square of a sum. Accordingly, the square of a summation of a variable, say x again, say x because we have used x in this notation. But again, x is just a dummy variable. You could use any other letter such as y, z, or any letters remaining in the alphabet. So it is the value as a result of squaring the summation of the variable. So it's the opposite actually of the sum of squares. If in the sum of squares, we are squaring each value of x first, and after squaring, we are going to add all of those squared values. In square of a sum, what we're going to do first is to get the summation of the variable. After getting the sum of the variables, we are going to square the result. That's why it is called as square of the sum. So it's addition first and then squaring. But in sum of squares, it's squaring first the value, then addition. They are actually the opposite one. Now let's try this hashtag Simpletivity. So we have here different values of x. So we have 2, 4, 6, 8, 9. We have 9 different values of the array. Okay, of the array, which is x. So the first value of x is 100. And the last value of x is 98. So we are actually tasked to get the square of a sum of the 9 values of x. So to do this, we just simply input all the values of x here. The first thing that we need to do is, please notice, we are going to get the summation, or simply adding all the values of x from the first value, which is 100, to the ninth value, which is 98. After getting the summation or the sum of all these 9 values of x, we are going to square the result. So the sum of all the 9 values of x is 849. If we are going to square 849, the result is 720,801. So the square of a sum of the 9 values of x ranges from 100 as the first value of x up to 98 as the last value of x is equal to 720,801. So as easy as that. So let's proceed to our hashtag stat techniques. In the sum of the square, the first thing we need to do is to square its value of x and then get the sum or the summation. But in getting this part here, which is the square of a sum, we are going to add first all the values of the array, or all the values of x or y or z, whatever that variable is. After getting the summation, we are going to square. So add the values first, then square the sum or square the result. And what's another difference? Sum of squares doesn't have parentheses, but the square of the sum, it contains parentheses. Actually, it really makes a difference, right? So sum of squares do not have parentheses because first thing to do is to square each value of x and then get the sum. It's definitely not equal to the square of the sum because we are going to get the sum first, or the summation of all the values on a given variable, let's say x or let's say y or z. And then after getting, because it's enclosed by a parenthesis, after getting the summation, we are going to square the result. Now, using the same data set that we used earlier in our problem set, we are going to compute for the sum of the squares and the square of the sum. So we have learned that we have here the weights of the 5 children. So the first child is 10 kilograms until the last child or the fifth child, which is 11 kilograms. We've learned that to compute for the sum of the squares, we are going to square each value of x first. Hence, we are already given the values of x. 10 kilograms for the first child, 12 for the second child, 14 kilograms for the third child, 8 kilograms for the fourth child, and 11 kilograms for the fifth child. So we are going to square each value of x. So 10 squared plus 12 squared plus 14 squared plus 8 squared plus 11 squared. That's equal to 625. That is basically the sum of squares. Again, we squared first, then we get the sum. Now let's try to compute for the square of the sum. So for the square of the sum, we have this parenthesis. The first thing that we need to know is to do the operation inside the parenthesis. So that is addition. That's why summation. So 10 plus 12 plus 14 plus 8 plus 11. Then after getting the result, then you're going to square it. That's why it's called the square of the sum, which is equivalent to 3,000 25. Please do notice that normally the square of the sum has greater answer or value or amount as compared to the sum of the squares. So is it easy or is it difficult? I hope you find it easy, okay? Another thing that we need to do about summation notation is the product of the sums or product of sums. So it is a value as a result of multiplying the sums of the variables. So we have here two variables. It's not only one variable anymore. We have another variable. So we have here summation of x and then summation of y. Or you could use any other dummy variable, summation of a by summation of b, or summation of g by summation of n. You could use any other letter. Again, they are just dummy variable or dummy letter. So for this one, so summation of x multiplied to the summation of y. So the first thing that we need to do here is get first the sum or add all the values of variable x, and then add all the values of the array of y. And then after getting the summation of x and then summation of y, we are going to multiply them. That's why it's called product of sums. Summing first, after summing, multiplying. Okay? And the opposite of this is the sum of the products. By the way, product of sums, we call this as POS, while sum of product is SOP. So another difference here is that for the sum of products, we could only notice one sigma sign. So we only have one sigma sign because this tells us that the sum of the products of two variables x and y is actually a value which results from the addition of the products of the values x and y. So here we are going, if we have x and y variable, x1 and y1, we multiply them, x2 and y2, we multiply them. After getting the two products, we then add. That's why it's called sum of products. How does it differ from POS or product of sums? So for the product of sums, if we have two values for x variable and two values for y variable, what we're going to do is to add first the two values of x and then add another two values of y. After getting the sum of the two different variables, we then multiply. That's why it's called product of sums. It's very literal. Okay, POS, product of sums, and SOP, sum of products. So let's try this hashtag Simpletivity. So given the values of x and y below, so we have how many values for the two variables? So we have 1, 2, 3, 4, 5, 6, and 7. So we have, so the values, if we're going to create a summation for this one, summation of, let's say we use I as the index of summation. Summation of xi as I goes from 1 to the 7th value. So if we're going to have a summation notation for this one, to get the summation, summation of y, let's say the index of summation is j, summation of yj as j ranges from 1 to 7, right? So we are tasked to get or to compute for the summation of x, summation of y, okay, the product of the sums, and then the sum of the products. So let's use our brain cells and tick by answering this. So get ready. So solving for the summation of xi. So summation of x, again, this is the sigma notation. Let's use this. Let's use my head. So this is the sigma notation. Let's enlarge. So we have here the sigma notation. This is the formula of the term xi. We have I as the index of notation. It ranges from the first value up to the 7th value. So To expand this, we have x1, the summation of x1 until x7. And we learned that we are actually given the different values. We have 15 for the first value, 9 for the second value, 7 for the third, until the last value, which is 16, the seventh value. So we are simply replacing the values of x here. So summation of x is simply adding 15 plus 9 plus 7 plus 12 plus 3 plus 7 and 16, which is the last value. So summation of x is equal to 69. How about computing for the summation of y? So to compute for the summation of y, again, here I use I as the index of summation. So we have here the sigma notation. Enlarging again, we have here the sigma notation. The formula for the term, summation index, which is I, it goes from y, which is not y, it goes from 1 rather, up to 7, the seventh value of y. So we have 1, 12, 8, 4, 11, 5, and 3, which is the last value. So to expand this one, you just simply need to, of course, put the index of summation. So it's y1 plus y2 plus y3 until the last value of y, which is y7. Then simply replacing each value by the real number. So simply adding 1 plus 12 plus 8 plus 4 plus 11 plus 5 plus 3, which is equal to 44. So please try actually to check my answers. So we have already obtained the summation of x and the summation of y. Now let's proceed to solving the POS. So POS, so we have here the product of sums. Again, if we talk about the product of sums, we will surely observe two sigma notations. So first is getting the summation of x and then getting the summation of y and then adding the two values of the two variables. So we have already learned that summation of x is 69 and that summation of y is 44. So we have already obtained these values previously in our computation. So the product of sums of what? Sums of variables x and sum of variable y. So it's 69 multiplied by 44, it's 3036. Okay, so that is the product of sums. How about the sum of product? So the SOP is this. So first is we are going to multiply first the two variables. So 15 times 1, it's 15. 9 times 12, it's 108. 7 times 8 is 56. 12 by 4 is 48. 3 by 12, or multiply by 11 rather, not 12, it's 33. 7 times 5, it's 35. And 16 times 3, it's 48. So if we're going to get the sum of products, then we are going to get the summation of the products of the two variable, which is 343. Okay, now it's your turn to do the calculation. Let's try this. Hashtag Simpletivity. So we have here two variables. We have variable x and variable y. So for variable x, it has three values, ranging from the first value to second value, which is -2, and the third value, which is 1. Y variable also, same with x. It has three values. Y1 is 4, Y2 is 2, and Y3 is 3. Now, we are tasked to evaluate, to do the evaluation. So, we are going to evaluate the products of sum and sum of products. So, this one, is this product of sums or sum of products? How about this one? Okay, please do remember, the easiest way to do this is that you could notice two sigma notations when we talk about product of sums. So between the two, B and the A1, which is product of sums, this one, okay, we are tasked here to get the product of the sums. While this one, we are tasked to get the sum of the products. Okay, the SOP here and the POS here. So let's start our evaluation. So we have the same given values for both variables x and y. So let's try evaluating the sum of the products. So the sum of the products of xi, yi, as I goes from 1 to 3, in order to evaluate this one, is simply multiplying first the value of x1 and y1, then multiplying also the values of x2 and y2, and multiplying the values of x3 and y3. After getting the results, we are going to add the different products. Remember, the answer to multiplication is what we call product, right? So xy1, 2 given here times 4, which is y1. So 2 times 4, it's 8, of course. And then x2 is negative 3 and y2 is 2. So negative 3 times 2 is negative 6. x3 is 1 and y3 is 5. So 5. So we have 8, negative 6, and 5 as the three products. So we're going to get the sum of the three products. So 8 plus negative 6, that's 2, plus 5, that's 7. So the sum of the products of x and y as I goes from 1 to 3 is equals to 7, given the following values of the two variables x and y. So let's proceed to getting the products of the sum. Let's try evaluating this second set. So the same given values, we are tasked to evaluate the products of the sum of these two notations. So let's try in expanding the notations. But before that, let's try to read the notation. So this is read as summation of xi as I goes from 2 to 3, or summation of xi as from I equals to 2 to I is equals to 3. So in this part here, we already know that we are only going to consider two values, the second value of x and the third value of x. While for this notation here, we are actually going to get we have square here. This is getting the sum of squares. So getting the sum of squares of j as j goes from 1 to 2. So still we are considering two values of y variable. The first variable, rather the first value of y variable and the second value of y variable. So let's try evaluating the first notation. It says to include the second value and the third value. We know that the second value is negative 3 and the third value is 1. So negative 3 plus 1, it's negative 2. So we're done evaluating the first notation. This is the summation, okay, of the first notation. The answer is negative 2. And then the other one is getting the sum of squares of y variable, including two values of y, the first one and the second one. So we learned that the first value of y is 4. So 4 squared, that's 16. And the second value of y is 2. So 2 squared, that's 4. So 16 plus 4 is equal to 20. So negative 2 times 20 is equal to negative 40. So this is now our answer to the given notation. So let's proceed now with our hashtag stat techniques. So if we happen to see this notation, remember we have seen two sigma notations or sigma signs. This automatically tells us that we are actually going to get the product of sums. So to do this, the first thing to conduct or to obtain is to get the summation of the first variable, which is x, and then get the summation of the second variable, which is y. So we have the summation sum of variable x and summation sum, right? Sum of variable y. After getting each summation, we are going to multiply. That's why it's called POS or product of sums. Meanwhile, we also have this one. So this is sum of products or SOP. So what we're going to do here is to multiply the variables first. So multiply the first value of variable x and the first value of variable y, or a specific value of x and a specific value of y. After getting their products, we are going to add the results. That's why it's called sum of products. Multiply the variables first, then add their products. That's sum of products.